Hey, this is Mr. Schultz, and today we're going to be looking at standard 7323, which is part of 7.2. This is the 7.2 part 1 worksheet. So you can either print off the copy of the notes from the Google Classroom, or you can also do a blank piece of notebook paper and writing utensil and just kind of reference that on screen, or whiteboard markers are great too. I'm a big fan of those. Big key here is be sure that you try this assignment first. I would like you to try instead of just watch all of these. If you get stuck, then come back here and watch the video. But this is a video, so feel free to pause, feel free to rewind, try some things, and come back. But let's get started here. So our goal of this section here is just that we're using scale factors to basically find the ratios or basically find out the side lengths that are missing. And the key is that the figures have to be similar. So let's take a look at what one of these looks like. All right, so this question says, use proportional reasoning to find the distance across the water. So I'm looking for this distance right there. So I'm looking for that x value. If I'm using a proportional reasoning, I should be setting up some sort of a thing where there are two fractions that are equal to each other. So I just need to figure out what are corresponding sides. So corresponding sides that I see here, I see that this small triangle, that kind of straight up and down side, should correspond with the x side. And then I can see that these kind of the base almost of this triangle should correspond with the base of this larger big triangle. So when I do this, I like to look at it in terms of scale factor. So what I like to do is I want to take all my small triangle measurements and I want to put them on one side. It doesn't matter which side. I just tend to put the small side here and the large side here, but sometimes I've changed around based off some random reason. So here I just say, well, I've got my 4.25 size and I've got my 8 size. And so I want to match those up and have them correspond. So this should be a corresponding piece, and this here should also be a corresponding piece. So what that means to you is that my 8 should correspond with my 12, and my 4.25 should correspond with my x. Now I've got my proportion set up, and I can just go ahead and solve. I like to use scale factor, so I'm trying to figure out what number. So 8 multiplied by some number here should equal 12. So if it's 8 times by some number, let's just call that some number, let's just say it's a number should be equal to 12. That's the same thing as saying that number is equal to 12 divided by 8. So if I just do 12 divided by 8, I come up with that number being 1.5. So my scale factor here ends up being 1.5. I'm going from 8 to 12, so I'm increasing by 1.5 times. So 4 times by 1.5. In this case, my x value ends up being 6.375. 6.375. Okay, so I went a little slow in that first one, but I'm going to start to pick up a little bit of speed. So Theo wants to know how wide the pond at the city park is. He drew his diagram and labeled it with the measurements. How wide is the pond? So basically he's looking for what is this x value here. Well, this x value is going to correspond with this small triangle. And then this side is going to correspond with this side. So I just need to set up my proportion and solve. So here I'm going to have my small sizes here. So I'm going to have 9 and I'm going to have 12. And then I'm going to have my x is going to correspond with the 12. And I'm going to have my 30 is going to correspond with the 9. So then using this scale factor approach, I'm saying how many times does 9 go into 30? So basically what number do I multiply by? Well, I should find out that scale factor is 3.3 repeating. So if it works up top, it should work down below. Be sure when you put this into your calculator that you're saying 12 times by 3.3333 and put a lot of 3's in there, because if you round that off, you'll get a slightly different answer. But you should end up with your correct answer here of x is equal to 40. So x is equal to 40. Let's see the next one. So Drew wants to know the distance across the river. He drew a diagram and labeled it with the measurements he made. What is the distance across the river? So I'm looking again for this x, and that's going to correspond with this. So if I think about setting up my proportion here, I've got my big triangle here. I've got my small one right here. So my big triangle is going to correspond. So that's x. That's what I'm trying to solve for. It's going to correspond with the 24 side on the small. And then on this other side here, I've got the 18 that's going to correspond with the 72. Well, the 72 goes on the big triangle, and the 18 goes on the small. So here when I start solving for this, I find out that I've got a scale factor of 4 because 72 divided by 18. Sorry, that's a really lame looking 2. 72 divided by 18, that's equal to 4. So that's my scale factor. So 18 times by 4 is equal to 72. So that means that 24 times by 4 should be equal to our solution. So in this case, x will be equal to 96. This would be 96 meters if you wanted to put that label in. All right, so this one looks a little different, so let's be sure to follow the instructions. So Scott is 6 feet tall and casts a shadow that is 15 feet long. At the same time, a tree casts a shadow that's 120 feet long. How tall is the tree? So this looks like a crazy problem here. But what I've really got is 2 triangles. I've got my small red one here that's got that 6-foot tall Scott and that 15-foot shadow. And then at the same time, I've got a second triangle here. And the second triangle is just this big one from the tree. So I've got my purple triangle that's got some height on it, but I know that the shadow is 120 feet in total. So this is really the exact same problem as our last one. I'm going to set up a proportion here and just say, okay, I've got my big sides here. So I've got the x and the 120. And the 120 is going to correspond with the same ground height here of 15 on my small triangle. And then the 6 on the small side there is going to correspond with the x. So again, to find that scale factor, if I'm going from 15 to the 120, 15 times by some number should be giving me 120. In this case, 120 divided by 15, well, that's going to be equal to 8. So my scale factor is going to be equal to 8. So that means that 15 times by 8 is 120. So 6 times by 8 should be equal to my solution. It should be equal to 48. And here's a little trick here. You can check your solution on this. What you're saying here is that this fraction should be equal to this fraction. So is 48 over 120, is that fraction reduced the same thing as this? So if I do 6 divided by 15, I get 0.4. When I do 48 divided by 120, I get 0.4. These two things are equal. I know that I've done this correctly. So now this one is going to be a very similar problem. I've got my 2 different size triangles here. So I've got the big one for the Eiffel Tower, and I've got this small one for the person. So I just need to figure out what measurements go where. So the Eiffel Tower is 300 meters tall and casts a shadow of 450 meters long. A person standing in front of a mirror is 2.5 meters tall. About how long is the person's shadow? So if I'm talking about a shadow, I'm talking about something that's going to sit on the ground here. So I'm looking for how tall is this person's shadow. If they are 2.5 meters tall, and here the Eiffel Tower is 300 meters tall, so the shadow is 450 meters long. So again, I'm going to set up my proportion. This is going to be my bigger piece, which is going to be the Eiffel Tower. Oops, that does not have an E there. It's got an I there. The Eiffel Tower. So I'm just going to put my height on top for no reason, and then the shadow on the bottom. And I'm going to line up the corresponding shadow with the smaller height of the person, and then I just need to solve it. So now here's something to pay attention to with scale factors. So it feels like, well, I need to increase this to go to 300. So I'm going to do that and just say that 300 divided by 2.5, and I'm going to find out that my scale factor here is going to be 120. So now it feels like, well, I just need to take x times, oh, wait a second, but this is backwards now. This is x times by 120 should be equal to 450. Well, I can still solve that for x. That's just like our normal one-step problem. So I'm just going to divide by 120, and I'll actually get that 450 divided by 120 is what x is equal to. So in this case, the person's shadow is going to be 3.75 meters long. Okay, much the same thing here. Person standing near a lighthouse has a shadow that is 10 feet long, and the lighthouse is 35 feet tall and has an 80-foot shadow. So again, I'm going to put my shadows in. So I've got 80 feet and I've got my 10 feet. I'm looking for the height of the person, and the lighthouse is 35 feet tall. Okay, so then we're going to take and we're going to set up our proportion and solve from here. So I've got the lighthouse, which is going to be the height. I'm going to put that on this side, and then I'm going to put a shadow down below. So this is the lighthouse side. And then I've got my person side over here. So I'm going to line up the shadow of the person and the height of the person is what I'm trying to find out here. So I'm going to go and start to make my comparison. So again, 10 goes into 8, so our scale factor is 8. So again, we're kind of left with this thing of x times by 8 would be equal to 35. So x times by 8 would be equal to 35. That's the same thing as x is equal to 35 divided by 8. I just have to work it backwards. So when I take 35 and I divide it by 8, x should be equal to 4.375 would be your solution. Okay, so this is our next layer here because you notice that we don't have any sort of a picture here. There's nothing here to go off of. So let's just read the question first and see what's happening. So the Washington Monument is nearly 555.5 feet tall and casts a shadow that's 225 feet long. A flag near the monument is 27 feet tall. About how long is the flag's shadow at the same time? Well, if I think about the Washington Monument, that's basically just kind of this straight up and down building that is super tall, looks something like this. And it's casting this shadow that looks something like this. And so the shadow of the Washington Monument is 225 feet long. And the Washington Monument is 555.5 feet tall. And then there's a flag. So I've got this flag that's near it. Let's just put the flag right over here for no reason in particular. So here's my flag. Feel free to judge my drawing skills. They are not super great. And the flag is casting a shadow in much the same way that the Washington Monument is. And so the flag is 27 feet tall. So on this side here, let me just zoom out just a little bit. The flag is going to be 27 feet tall there, and I'm looking for how long is the shadow. So now I just have to set up my proportion and solve. So I'm going to just set up my proportion here. So I'm going to take my bigger triangle and I'm going to put the shadow on the bottom. There's really no reason to do that. I just do it for consistency's sake. But it doesn't matter if you put the shadow on top or the bottom. Just be sure to match it on the other side. So my shadow, my shadow, and my shadow, my height, and my height. Now I'm going to continue using the scale factor approach, but if you prefer a different approach for solving these, use that approach. This is just the one that I'm showing here. So again, if I'm finding that scale factor, well, 75 goes into 555. This weird number, it's 20.57407407, just kind of weird. But this is just asking for about how long. So I might just round this off. I might just call this 27 or 20.57. And so then it's going to be the same scale factor here. So again, since I'm kind of working this backwards, I just need to divide instead of multiply. So 225 divided by 20.57. And then just see what my solution is going to be equal to. So in this case, something around 10.9, I think is awesome. So this flag's shadow is about 10.9 feet, roughly. So again, back to our no picture stuff. So I'm just going to read the question. So a person is 5 feet 3 inches tall and casts a 6-foot shadow. At the same time, a lamppost casts an 18-foot shadow. And what is the height of the lamppost? So let's make my drawing here quick. All right, so here's my amazing drawing. So a person is 5'3", so they're 5 feet 3 inches tall, and they cast a 6-foot shadow, and the lamp casts an 18-foot shadow, and I'm looking for how tall is the lamp. So that's my X right there. So we're going to set up the proportion. So all this stuff is pretty straightforward. I've got the shadow and the shadow. I've got the height of the lamp and the height of the person, but 5 feet 3 inches. That's not 5.3, because remember that 3 inches, so that's 3 inches out of 12 inches that make a whole foot. So 3 out of 12 is 1/4 or 0.25. So if I convert this to a decimal, I would just change that to be 5.25. That'd be 5 1/4 foot. So then again, I'm going to find my scale factor. So 6 times by some number is 18. So that should be 3. So I'll just use that same 3 number there to find out my height here. So 15.75 feet tall is the height of the lamppost. So again, another problem that doesn't have any sort of an image. So a warehouse is 120 feet tall and casts a shadow that is 288 feet long. Same time, Julie, who's a person, casts a shadow that is 12 feet long. How tall is she? So let's draw this picture. All right, so here's my picture. I've got the warehouse. The warehouse was 120 feet tall, and the shadow is 288 feet long. And Julie is over here, and her shadow is 12 feet long, but we're trying to figure out how tall she is. We're trying to figure out this height here, but we know this height here. So let's set up the proportion. So the proportion, I'm just going to say the height of the building divided by the shadow should be equal to Julie's stuff. So Julie's height is x, we don't know it, divided by her shadow, which is 12. So then last step, I'm just going to find my scale factor. So how many times does 12 go into 288? Goes in there 24 times, so 12 times by 24 would be equal to this. So going in the opposite direction, instead of going this way, that means that I should be dividing by my scale factor from going this way. So then in this case, 120 divided by 24, that should be equal to 5. So that tells us that Julie is 5 feet tall. If you're getting crazy answers like 60 feet or some big or really small number like half a foot, that should be a good indicator to you that you've maybe set up your proportion wrong. So you can double check that too. Use proportional reasoning to determine the height of the flag and the girl. So I've got the flag right there. I've got the girl right here. So I'm back into having images. So I just need to set up 2 sets of proportions. So let's start off by setting up the one with the girl. So I'm just going to set up and say, okay, my tree height is 51 and my tree shadow is 119. The girl height, I'm not sure. That's what I'm trying to figure out. But the girl's shadow is 7 feet. So jumping back into scale factor here, I'm just going to figure out how many times does 7 go into 119. So 119 divided by 7. I should get 17 as my scale factor. But again, I'm going that backwards route. So I just want to say 51 divided by 17 should be equal to 3. Now 3 feet feels a little short. So this would be a good one to check. So I'm just going to say, is 3 divided by 7, is that number, which is some crazy decimal, we'll call it 42857 and some more stuff, is that the same number as 51 divided by 119? In this case, it is. It's that 42857 da 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 da. So I know that this answer is correct, even though it seems a little short. Let's see the second one. So in this one, feel free to pause the video and check it out. But same type of thing here. I'm going to set up that same 51, that same 119. The flag is 84 feet on the shadow, and then I'm trying to figure out how tall it is. So again, I'll use scale factor to find out what that is. So 84 times by some number equals 119. So that's 119 divided by 84. So I get this kind of weird decimal. It's not too crazy, but it's 1.416 repeated. So that's the same scale factor here. Let me change that for 1.416 repeated. So I just need to work that backwards and say 51 divided by that 1.416. And just be sure to put a lot of sixes in there so that you get the exact number. You should come up with that the height of the flag is 36. So x is equal to 36 feet on this one. More of the same here, so be sure that you're paying attention on if you're supposed to be doing the odds or if you're supposed to be doing the evens. Depending on your teacher, you might be doing different problems here. So again, we're going to set up a proportional reasoning to determine the height of the house. So I'm looking for how tall is this piece right there. So I'm going to say my height of the house, I don't know, but its shadow is 72. The height of the I don't know, we'll call that a bush there, is 4.5, and the shadow is 9. So 9 goes into 72, and it comes out with 8 times as my scale factor. So 8 is my scale factor here. And now this one's good because I'm still moving that same direction. 9 times by 8 is 72. So I've just got to do 4.5 times by 8, and I should come up with that x is equal to 36. So the height of the house in this one is 36. Now in 12, the tree in the picture above, so this tree here is 56 feet tall. So I just need to set up pretty much the exact same thing. I'm going to use the height of my bush just because those are the given numbers. So I'm going to stick with those two things. And now I've just got that the height of the tree is 56. But I'm trying to figure out how tall would the shadow be. So much the same type of thing here. So I just need to figure out the scale factor. So 56 divided by 4.5. I should end up with kind of a weird number, 12.4 repeating. That should be the same number down here. Now 4 times by 12.4 repeating is 56, so 9 times by 12.4 repeating. Make sure that you add a lot of 4s when you're doing the multiplication because then you'll get that nice number at the end. So x is going to be equal to 112, so the shadow of the tree is going to be 112 feet. An isosceles triangle has a base of 8 inches and legs of 12. how wide is the base of a similar triangle with legs measuring 36 inches? Well, an isosceles triangle, that just means it's a triangle where these two sides are the same. They're just two sides that are the same. So I've got one that looks like this, and I've got a similar one. So it might be smaller, it might be bigger. In this case, I should draw this differently because it is bigger. So my first one has a base of 8 inches, so the base is 8. And then it's got legs of 12. Well, if they're the same, it doesn't matter which side because both of these are 12. And then how wide is the base of a similar triangle? So I'm looking for the base of a similar one. If it's got legs that are way bigger, pretend that that's a really greatly drawn isosceles triangle there. And these are 36 inches. This one, it's even easy to kind of see this scale factor and say, oh, well, this is just 3 times larger, so therefore this has to be 3 times larger too, so that it would be 24, which is your correct answer. If you want to see that using the proportional reasoning, you could just say that your 12, so your legs divided by your base should be equal to your legs divided by your base, and you can see that scale factor here still, and just say, okay, this is multiplied by 3, so this has to be multiplied by 3. The base is going to be equal to 24 on this one. All right, so use proportional reasoning to find the missing one. So again, we're just kind of looking at these corresponding things. So I'm going to go and I'm going to say, okay, my kind of straight up and down edge of the small triangle is 6, and then my kind of base side is 9. So then of the bigger triangle, I've got a base here of 27. So let's be sure to line that up with my base. So my base and my base are both together in that same plane. And then I've got my height and my height are both together on this kind of same plane there. And then I just need to set it up and solve. So here, I'm going to find the scale factor. So 9 goes into 27 3 times. So my scale factor, 6 times 3, x is going to be equal to 18. So that means that the height of the big triangle here is going to be 18 feet. And that's it. Please reach out to your teacher if you have any questions about any of these problems. They would love to help out.